Hello guys, welcome to the BODG 1022 Building Structures Mentoring session today. My name is Jesse. Today I'm doing a revision session on formulas and calculations about vectors, static equilibrium, stress, and strain. I hope you find the information from this session useful. A little bit of introduction about myself. I am a graduating student in the construction management and property major. I have previously completed the course in 2019 with a distinction mark. On top of that, I have previously worked in the residential sector of the industry before pandemic took place, and I'm your mentor for the subject this term, and I hope I'll be your future workmate in the industry. So now I'll be sharing some of my experience on solving calculation-based questions. I understand that this course can be very challenging sometimes, due to its nature of formula-based and the complexity of the concepts. So the first thing you need to do is to have a decent understanding of the concepts, laws, and formulas from the lectures. If you have encountered any difficulty on this one, you should contact your lecturer, Dr. Samad, and your tutors for help. Secondly, you will be needing to decipher those formulas into common language. What I mean by that is you need to understand what those symbols stand for and what are the concepts those initials stands for. When you finish that step, you will be need to interpret the question in front of you, and you need to understand what are the appropriate formula for solving this question. Then you'll need to determine what's known and what's unknown, which is the answer this question is asking you. Also, the benefit of determining knowns and unknown will make it more clear that the relation between all the, say, forces and vectors in the questions. And after which you'll be substituting the figures from the questions into the appropriate formulas to calculate the answer. I want to remind you to be careful when you converting units, especially you were converting something like kilometers per hour to meters per second when the conversion of units is no longer simply a replacement of decimal point. And in the end, I would just want to say just practice and practice, because practice makes perfect. So the first concept I'll be explaining today is vector operations. This is a concept that's associated with force decomposition, which I'll be covering later in the session. So vector, first, by definition, is a quantity, has both magnitude and direction. In vector operations, we have a formula to determine the resultant vector's quantity. It is the quantity of the resultant vector equals to the square root of vector 1 square plus vector 2 square. For direction of the resultant vector, we have two laws to determine that. The most common method is usually the triangle construction, as seen in the graph on the left. Alternatively, you can also use parallelogram law to determine the direction of the vector. As you can see in the example on the right, there is two vectors, and you'll be asking what is the direction and the quantity of the resultant vector. So first off, both of the vectors have the same quantity, 11 kilometers. One of them goes to the north and the second goes to the east. So naturally, the resultant vector's direction is northeast. Secondly, as we already have the formula to determine the quantity of resultant vector. Simply substitute the quantity of both vectors into the formula there. You'll have the quantity for the resultant vector. Next, we have the Cartesian vectors. This is an example that vector operations can also be presented in a 3D format. To solve a question like this, you can use trigonometric function. Alternatively, you can also determine a resultant vector in 2D, and then you can take into account the effect of the third vector and to figure out the actual resultant vector in the question. When vectors are associated with forces, we have a very similar formula to determine the quantity of the resultant force as we did to determine the quantity of the resultant vector. However, when the vectors are associated with forces, we are supposed to take into account the effect of gravity acting on an object. So here we have a statics equilibrium calculation question from earlier this term. I'll be walking through the question using the method I mentioned earlier in the session. The question being the object weighs 12 kilograms, the setup with two cables, cable A and cable B, is in the state of static equilibrium. The question asks you to determine the tension in both cable A and cable B. Let's take a look at the questions first. It says the setup is in the static equilibrium. This means all forces acting on the object are balanced. Therefore, we can simply set up a coordinate system using the object as the starting point. Secondly, we can say that the object have a weight of 12 kilograms. As I mentioned earlier in the session, we need to take into account the effect of the gravity, which equals mass of the object plus the acceleration rate of the gravity. Next, the angle of the cable A and cable B with the ceiling is known, as the x-axis is parallel to the ceiling. Therefore, the angle between cable A and B with the x-axis is the same. However, as it can be seen in the graph, that the cable A and cable B is not exactly in the same direction with y-axis and x-axis. Therefore, what we need to do now is to decompose those tensions into x-axis and the y-axis. After we have finished the force decomposition, due to the fact that we know from the question the setup is in static equilibrium, we can know that the cable A's tension affecting on the x-axis balances with the cable B's tension affecting on the x-axis. On top of that, the cable A and cable B's tension effect on y-axis combined will be balancing the effect of the gravity on the object. Lastly, we have all the information we need to solve this question. Let's now move on to the next slide and put all this information into formulas and do the calculation. With all the information we have from the analysis earlier on, now it's time to determine the knowns and unknowns, substitute figures into equations, and calculate the answer. As we know, all the forces acting on the y-axis balances with each other, we can say that tension A multiplied by sine 60 degree plus tension B multiplied by sine 40 degree minus the gravity of the object equals 0. However, in this equation, we have two unknown, tension A and tension B. To solve that, we can use the equation that all the forces on the x-axis balances each other, which can be translated into tension A multiplied by cosine 60 degree equals tension B multiplied by cosine 40 degree. In that way, we can calculate a relation between tension A and tension B, that tension A equals 1.532 times tension B. After which, we can substitute this conclusion into the equation of all the forces acting on the y-axis. Now we can substitute all the known figures into the equation, as the equation only have one unknown figure, tension B. After calculation, the tension B should be 59.7 Newton meters. Now we can substitute the quantity of the tension B back into the relation between tension A and B, and finally we can calculate the tension A equals 91.5 Newton meters. Moving on to another section, stress. By definition, stress is the quantity of magnitude of forces that cause deformation. This deformation can be in the form of compression, where the total length of the subject reduces. It can also be in the form of elongation, where the total length of the subject extends. Please note that the stress is usually evenly distributed to the cross-section of the body. In this course, the formula that we usually to calculate stress is stress equal to force acting on the cross-section divided by the area of the cross-section. The unit for stress is Newton per square meter, or Pascal, which is named after a French physician, Blaise Pascal. Lastly, please be careful when you converting the units for stress. If you look at the bottom left of the slide, you will note that a megapascal equals to 1 Newton meter per millimeter square. Please be careful when you encounter a unit like that. Moving on, we have another example calculation question here. This one is also from your slides, pretty simple. An 80 kilogram lamp is supported by a single electrical copper wire of a diameter of D equals 3.15 millimeters. The question asks you what is the stress carried by the cable. So let's do a force analysis first. The only force that's been balancing on the object is the tension of the cable and the gravity on the object. Therefore, the force that's causing a deformation or has the possibility to carry out a deformation on the copper wire is the gravity of the object. Therefore, we have the force equals to mass multiplied by gravity acceleration, and since we already have the diameter of the copper wire, we can easily use the formula to calculate the area of the cross section of the copper wire. After we have done both of that, we simply divided the gravity by the area of the cross section. We can have the stress being 100.6 megapascal. The tricky part in this question is that they only give you the diameter of the copper wire while calculating the cross section. People often use the radius of the cross area. Therefore, you usually need to convert the diameter into radius. Lastly, I want to remind you to review the international metric system and the conversion of units, and also the placement of decimal points. As you can see, the cross-section area is having the unit of 10 to the power of -6 square meter, and you need to convert that to Pascal and then convert Pascal to megapascal in this case. Finally, we've come to the last part of our session today. Strain. Strain by nature is a deformation caused by force acting on the object. Normal strain can be calculated by the formula that deformation length divided by the original length of the object. Deformation length is the difference between the deformed length and the original length of the object. Deformation can be presented in two forms: compression, where the deformed length is shorter, and elongation, where the deformed length is longer than the original length, which is the scenario in the graph here. Lastly, I want to remind you to be careful about the symbol between stress and strain. They can be very easily confused with each other, especially when they are appeared in the same question that asks you to calculate both of them. Hi folks, this is the end of the sharing today. Thank you for tuning in, and I hope you enjoy most of the session so far. As you may have already noticed, we're heading towards the end of the trimester now, which means the final exam period is approaching. So here are some advice for your final exam preparation. First off, I hope you can make some time to revisit all the concepts, basics, formulas, calculation sample questions in your lectures and tutorials. These contents are the knowledge foundation for the course, and they will also help you to secure at least half of the mark in the final exam. If you have met any sort of difficulty, please do not hesitate to reach out and seek help. Dr. Samad, your tutors and mentors, will help you along the way, whether you have difficulty in the formulas or concepts, or you simply need help to revisit all the contents we have delivered so far. You can reach me through email address here. Also, if you need some more clarification on the contents and calculation I have covered today, or you have any suggestions for the contents I'll be covering for the next session, please don't hesitate to contact me through the email address here. Next, the most important part of the final exam preparation is that you need to do your own part of the work, that you need to earn those marks yourself, that you are the biggest help that you can have for yourself. Therefore, I suggest you to practice often and start right now. Remember, a 1,000 miles trip starts with a single step. Lastly, I hope you can have faith in yourself that you got this exam, you can pass the course, and I would like to wish the very best for your exam and the revision so far. Thank you for listening today. I will see you next session.